This video will cover section 4.5, the graphs of sine and cosine functions. We already did an activity in class where students were able to unwind the unit circle to construct sine waves. So right now we're just going to go review them briefly. I was explaining how one period goes from 0 radians to 2 pi, and this is for the parent function of the sine function. So right here, if we look at the graph that we have here, we have one period going from 0 to 2 pi, another period going from 2 pi to 4 pi, and then we have another period going from -2 pi to 0. And if you notice, we do have those arrows at the end, so that implies that it keeps going, right, in both directions. This will be like the starting of a new period, but not completed, okay? However, the domain is all real numbers, so you can go in both directions. Okay, so let's look at the table of values, and so you know that it does resemble the unit circle. So if you remember, or if you don't, this will be a good time to learn, the sine of 0 radians is equal to 0, right? Because if you picture that unit circle, you're here, right here, right? So the y-coordinate is 0. Now, if we move on to, let's say, pi over 2, this is what I want you to do in your head, okay? And then what is the y-coordinate here? 1. Okay, and then, so you see the 1, right? Now, at pi, I want you to do this in your head. What is the y-coordinate there? 0. So you see the 0 there. Now, at 3 pi over 2, you will be here. What is the y-coordinate there? -1. Okay, very nice. And then if we complete the turn, 2 pi, what is the y-coordinate here? 0. All right? So let me see what's on the next slide. Okay, so these are some guidelines for you to graph it, and then you'll see in a minute what I mean by all of this. So we're going to be finding 5 points, which we're going to call the key points. And so those key points are going to be the ones that I'm going to mark here, okay? Okay, so as you can see, we have 3 x-intercepts, right? So x1 will represent an x-intercept right here. x3 will represent an x-intercept, and then x5 will represent an x-intercept. That is if the graph doesn't have any horizontal or vertical shifting, okay? So it will always work like that. The first point will be an x-intercept, the last point of the cycle will be an x-intercept, and the point that is right in between, which we could call the midpoint, it will also be an x-intercept, all right? Now, if your graph is not reflected across the x-axis, then the point that will come between the first 2 intercepts, right here, is going to be the max. Well, the y value will be the maximum value, and the x value is where it happens. So this will be the max, and this one here will be the minimum. Remember, the minimum is the y value, and it happens at 3 pi over 2. So now let's look at the guidelines here. We're going to go over them, and we have here something saying you need to identify the amplitude and the period. The amplitude is going to tell you how vertically stretched your graph will be. And so the amplitude is actually defined as the distance from the maximum point to the minimum point divided by 2. But I think that the easiest way to find the amplitude is by looking at the coefficient that your function will have in front of sine, and that will tell you what the amplitude is. So for the parent function, the amplitude is 1. And therefore, the minimum value, y value is -1, the maximum y value is +1. The period, I think you guys already know, what's the period for sine function?
20 minutes.
No, that's for women. 2 pi, just 2 pi. So one full cycle is 2 pi, all right? Now, once we have that, we have here, the handout is talking about those 5 key points. And so we have the 5 key points where 3 of them will be x-intercepts. We will have a maximum point and a minimum point, okay? And I'll show you in a minute how we're going to find them, but just to give you a little preview, we will be finding the distance between those key points by dividing the period by 4, because there will be 4 spaces in between. Let me show you what I mean by that. Okay, so we do say there are 5 key points, right? 1, 2, 3, 4, 5. Well, how many spaces are in between? 1, 2, 3, 4. So because of that, that's why we gotta divide by 4 here, all right? Just to find the distance in between one key point and the next. But you will see that. We're gonna graph several examples. And of course, once we have the x values of the key points, we still need to find the y values. And then pretty easy, we will connect the 5 key points with a smooth curve, so no sharp turns. And then we extend the graph as desired. So we already know the domain is a real number, so we can extend it, right, until we die, but we're not going to do that. So sometimes I might ask you, just graph 1 cycle. So that will be just from 0 to 2 pi, and you're done. Sometimes I might ask you, graph 2 full periods. So then you might have to go all the way to 4 pi. Or you might have to go to negative 2 pi and constant 2 pi. All right, on my math lab, you guys know you're going to be graphing on my math lab, and it's fairly easy, right? Probably the hardest thing is to get used to the buttons that you press. But I do want you to practice how to graph on paper, because that's how you will be graphing on your exam, okay? All right, so before we graph this too, let's just go ahead and graph the parent function on our own. So we're going to start by graphing the parent function of the sine wave, and we're going to write it as y equals to the sine of x. Now in this case, you might be thinking, you told us x belongs to cosine and y belongs to sine. I want you to forget that for a minute and think about, now instead of using theta as our independent variable, we're going to use the angle as the independent variable, and so therefore they are located here on the x-axis. So x is taking place of theta. The dependent variable will be y, and so that will be either a number where the parent function, it cannot be greater than 1. So I want you guys to count 2 units and make that a 1, and then same thing here. Let's make this a negative 1.
Would it be what you told me, like 1/2 and square root of 2?
Yes, let's do that. Let's do it at the end.
Okay.
Yep. Okay, so let's graph those key points, the 5 key points. Well, first of all, let's amplitude is equal to the absolute value of 1, so it's just 1. So that means that the range will be from -1 to 1, including those 2 numbers, so that's why I use brackets. And so you could tell that the maximum value, which is the y, will be 1, and the minimum y value will be -1, okay? Now the 5 key points are going to be in this way. So we have x1 will be 0. So the first one and the last one will be 0 and 2 pi, and those are going to be x-intercepts. The one in between, that will be pi, will also be an x-intercept. Now, the point that is in between the first two intercepts is going to be pi over 2. And so that one is going to give us the maximum value. So it should be here. And now the point that is in between the last two x-intercepts, which is 3 pi over 2, will be the minimum. So that will be, the y value will be at -1. In fact, the minimum is the y value. It happens at 3 pi over 2. Now I'm going to connect them with a curve. And I'm going to go ahead and graph it in on the left side of the y-axis as well. So I want you to think about negative angles, all right? So if we want negative pi over 2, look at the board, please, and we will go in this direction, right? So what is the y value there? -1. Okay, then we get to negative pi. I'm going clockwise because we're talking about negative angles. So negative pi, what is the y value there? 0. And then we go to negative 3 pi over 2. What is the y value there? 1. And then we get to negative 2 pi, so that would be 0. So we can connect this wave in this direction as well. And of course, it does keep going, so I have arrows on both sides. Now, here on the y-axis, I'm also going to label the values that correspond, let's say, to pi over 4. And so, what is the sign of pi over 4, guys? Correct. So right here, that should be the square root of 2 over 2. Now, let's see about pi over 6. And pi over 6 is somewhere here. What is the sign of pi over 6? 1/2, guys. 1/2. What's the sign of 30? 1/2. What's the sign of pi over 6? 1/2. Okay, and then here I'm going to place pi over 3. And that one corresponds to the value square root of 3 over 2. Okay? So if you notice, all of them are less than 1. Yeah? All right, so that's it for the parent function. Let's just write down the domain, just so you don't forget. It's all real numbers. All right, so we're going to go back to the handout now. Now we're going to graph a variation of the sine function. It's almost the same. The only thing that is changing is the amplitude. Okay? So I know the amplitude changed because here the equation, it has a 1/2 in front of the sign. So that means that it's multiplying all of the y values or all of the output values by 1/2, making them smaller or bigger?
Smaller.
Smaller, right? So that is going to be actually a vertical shrinking. It's going to do this to the graph. All right? So the amplitude here will be the absolute value of 1/2, which is just 1/2. And so that means that the range for this function is going to be -1 to 1. I'm sorry, -1/2 to +1/2. Since we don't have any type of vertical shifting, we could know right away that the maximum will be 1/2. And I'm talking about the y values, and the minimum will be -1/2. So what I'm going to do here, well, let's just write down the period. And that will be 2 pi. In general, the period is found by using the regular period of a sine function and dividing it by the number that multiplies the x. In this case is a 1. So it's just the same as the parent function, 2 pi. We're going to graph, in a few slides, we're going to be graphing some where the period will change, okay? And then you'll see what I mean. Now, what we're going to do is, I'm going to show you 2 ways you can find those key points. Well, first of all, let me show you this. Since the period is 2 pi. How many spaces are in between the key points? 4, right? We have 5 key points, but there are 4 spaces. So we divide by 4, and we will get, we could simplify here, so this will be pi over 2. So what that means is that the distance between every point is pi over 2. So you can see we start with 0, we end with 0, but if we have x1 is 0, x2 will be 0 plus pi over 2. So that's how you get this one here. The next one, x3, will be pi over 2, and then you add another pi over 2, and so you will get pi. And that's how we get this one here. And then for x4, it will be pi over 2, I'm sorry, not pi over 2, but just pi, plus pi over 2, and so that will be 3 pi over 2. Now this one is not really difficult because it's almost the same. Actually, it's pretty much the same as the parent function, right? So this will give us 4 pi over 2, which is equivalent to 2 pi. Now that we have our 5 x values, we're going to find the y values that correspond to it. So here what I'm doing is I'm going to substitute the x value there. So the very first one will be 1/2 times, what is the sign of 0? 0. So that will be 0. And then we have 1/2, what is the sign of pi over 2? 1. Remember, I want you to, with your brain, locate pi over 2, okay, in your head. All right, next, 1/2 times, what is the sign of pi? What is the y value here?
0.
So 1/2 times 0 is 0. Okay, then once you get down to 3 pi over 2, what is the sign there? Negative what?
1.
Okay, so 1/2 times negative 1/2, times negative 1 is negative 1/2. And then the last one will be 1/2 times, what is the sign of 2 pi? 0. So this is 0. So let's go ahead and graph it quickly. If you notice, we have the same key points, so it should be pretty easy, right? And so for that graph, I would like you to use the other paper, that one. So here we're graphing 1/2 times sine of x. So what I want you to do is count 2 units, and that will be a 1. So the 1/2 will be 1 unit. And then negative 1/2 will be here, and this is negative 1. Now you could always label the x-axis and the y-axis to your convenience, if it's not already labeled for you, as long as the intervals are proportional, right? So if I say this is pi over 2, right here, then 4 units, that will be pi. And then 2 more units, that will be 3 pi over 2. 2 more units, that will be 2 pi. Then if I keep going, what would that be?
5 pi over 2.
Yes, 5 pi over 2. The next one is 6 pi over 2, which happens to be 3 pi. And then we have 7 pi over 2. And then we have 8 pi over 2, which is 4 pi. And then we will have 9 pi over 2.
Yeah.
And then 10 pi over 2, which is
5.
5 pi. And I don't want to graph that long, but I just wanted to show you how to label. This will be negative pi over 2. Right here, we could have negative pi. All right, so we're going to graph the key points, our x-intercepts, starting with those. So those will be at 0, at pi, at negative, and at 2 pi. Now, our maximum point is going to be here at pi over 2. The maximum y value is 1/2, so that will be there. And the minimum point is going to be in between these 2 intercepts, and that will be here at negative 1/2. So I'm going to connect the curve. Connect the points of the curve, and that will be one cycle. However, I can keep going in both directions, and it will look like this right here, and then it will go back up, and I can do the same on the right side. So we go from minimum intercept, and then we will have a maximum, and then an intercept, and then a minimum, and then an intercept, and then a maximum, an intercept, oops, an intercept, and then a minimum, and then it will go back. Huh? Yes, it's not that hard. Oh, very nice, very nice. And then if you see like my name more than once, just put me once.
Oh, you're only in there once.
Okay, good.
People paid some that pay $10. Should I put them again?
Put him twice, yes.
Okay, so.
Yes, put him twice. Hi, Miss Andrews.
Hi. Are you testing?
No, we're just.
So everybody go ahead and get up, leave all of your stuff here. And exit before the
Everyone's
Stop doing that.
No, she's doing something.
I'm just kidding.
Jeff had class.
Bring
She's
it all
doing
over.
treasures.
A lot of kids here.
Look for a schedule.
There's a lot of kids in this. This is good.
Easy.
All right, moving on to example 2. That's going to be the function that you guys see here. That you see here. So, if you notice, what is different from the parent function that we see here? The what? The coefficient, right? That -2. And so the amplitude is going to be a little different. So the amplitude will be the absolute value of -2, which is 2. So that tells me that the minimum value will be, the y value will be -2, and the maximum y value will be +2. So the range for this function will be from -2 to 2, including those two numbers. Now, the period is going to be the same as the parent function because we have a 1 here, the coefficient of the x, of the actual angle. So it will be 2 pi divided by 1, so it's just 2 pi. Now, to find the space between the key points is going to be the same as the previous function because we will have 2 pi and we have 4 different intervals, and so that will give us pi over 2. So to find our key points, of course the first one is 0 because there's no horizontal shifting. The last one will be 2 pi. The one in between those two, those will be the x-intercepts. And then here, right here, this one will give us our max, well, actually not the maximum. It's going to give us the minimum. Why is that, guys? And this will be the max. Okay, let's do it here by substituting. Let's see if it's true. So we already know those will be zeros, right? Yeah? Do you guys believe me?
Yes.
Okay. It will be 0 because the sine of pi over 2 is 0. The sine of 0 is 0. The sine of 2 pi is 0. That's why there will be 0. Okay? Now for the minimum, we have -2 times, what is the sine of pi over 2?
1.
1. So that will be -2 times 1, which is -2. Then here we will have -2 times, what is the sine of 3 pi over 2? That will be -1. And so -2 times -1 is +2. So you guys notice this x value gave us the maximum, and this x value gave us the minimum. So we're going to have the points, and the reason for that is that this graph has a negative in front of that too. And so that negative is reflecting the graph across the x-axis. So instead of looking like this, like the parent function, our graph is going to start at 0, and then it's going to go down, intercept, and then up. All right? That will be our reflection. So let's go to the graphing paper. The one with 4? Yes, the one with 4 on each page. Okay, and so here we're going to be graphing -2 sine of x. Thank you, Michelle. Now the period hasn't changed yet, so let's just do the x-axis the same way, pi over 2, and then pi, yeah, that's okay. And then 3 pi over 2, 2 pi, and just keep doing that. 5 pi over 2, 3 pi, 7 pi over 2, 4 pi, yes. And then in the negative direction. Now, with our y-axis, what I want us to do is, let's go ahead and consider this to be 1. 2 units will be 1, and then 4 units will be 2. Same in the negative side, that will be -1, and here we will have -2. Okay. So now let's graph our 3 intercepts. So one at 0, one at 2 pi, and one right in between, which will be pi. And then remember our next point, the one right in between the first 2 intercepts, was the minimum point, and that was here. It happened at pi over 2, but the minimum value was -2. So our graph will look like this. And then it's going to go up to the maximum point that happens at 3 pi over 2, and the maximum is +2. And you could just kind of follow the pattern. All right. How How many full cycles do you guys see here? Or full periods? All right, so here's one. That's one. And then here's two. Oops, right there. That's it. Those are the only two full. These are just the parts of the next one. Okay, let's go back to the handout now. Okay, so we need to move to the next slide. All right, now we're going to look at a graph where the period is different. And so what the period does is it's going to either stretch it horizontally or shrink it horizontally, okay? And actually yesterday, Chris, he asked me, does the period have anything to do with the frequency? And the answer is yes. And so all of you engineers are going to work with that a lot, with frequency and period. But guess what? You doctors are going to work with that too, because a lot of human behaviors, they could be portrayed in cycles, which is that one, not just the female thing, monthly. Okay, I'm talking about like your respiration, your cardiac rhythm, or your sleeping cycles, or so understanding this type of thing is very important. Now, frequency is, we're going to get to some problems with that, but I'll just mention it in a minute. Let's go to period first. So, amplitude, we already know how to do that, right? And so we take the amplitude from this constant here. So the amplitude is the absolute value of 3, which is 3. Now, for the period, we're going to consider the regular period of a sine function and divide it by this constant here, which is the 2. So if we do that, we end up with just pi. So what that tells me is that my 5 key points for a full cycle are going to be, the first one will be 0, and the very last one, if you notice, it will be pi. Okay, that will give me a full cycle. From 0 up, down, and then again. That's what I mean by a full cycle. Okay, so it will be from 0 to pi. Now, let's see what is the space in between the points. And so for that, we take pi, and we divide it by 4. And so that just gives us pi over 4, right? So pi over 4 is the space between the points. So we could do it this way by finding, okay, x1 is just 0, x2 will be 0 plus pi over 4, which is pi over 4. x3 will be pi over 4 plus pi over 4, like we just keep adding pi over 4. That's how you do that. And so you get pi over 2, because pi over 4 plus pi over 4 is 2 pi over 4, which is pi over 2. Do you guys remember how I used to tell you, get used to fractions? Get used to fractions. No? No? Okay. So the next one, x4, will be pi over 2 plus pi over 4. So in this case, we're talking about 2 pi over 4 plus 1 pi over 4, so that is 3 pi over 4. And the very last one is 3 pi over 4 plus pi over 4, so that is 4 pi over 4, which is pi. Now, of course, you always ask, is there an easier way? Yes, there is an easier way. And I actually like to do this better. I like to think about, if I'm graphing sine, I'm going to start with the 3 intercepts. And so those will be where the graph starts, where the graph ends, and right in between, the midpoint. It has to. And then I look at, is this graph being reflected or not? Is this one being reflected across the x-axis?
No.
No. So that means that the point that will go right in between the first 2 x-intercepts is going to be the max. And what is the maximum value? No. The maximum y value. Remember that comes from the amplitude, so yes, it is 3, and the minimum will be -3. So that means that here the maximum will be 3, and the minimum, the x value where the minimum happens will be in between these two intercepts, right there. And how do you guys get a midpoint? Do you guys know? What if I didn't know this was 3 pi over 4? If you get 2 exams and I tell you to calculate your average, you're pretty good at that. What do? Yes. So let's see, if we add pi over 2 plus pi, we will get pi over 2 plus 2 pi over 2. We add them, so that will be, oh, and we're dividing all of this by 2, right? So then it will be 3 pi over 2, but we're dividing by 2 because we're getting the midpoint, and so that will be 3 pi over 2 times 2 is 4. So that's another way you can get those points. Some people who are more visual, you could also do that. So let's move on to graph it. So the y value here was the minimum, right? We agree on that? It was -3. Let's go ahead and graph it. No. What was the equation, guys?
A equals 3 sine 2x.
Okay, and so we decided that that was pi. Let's go ahead and make here the y-axis be 3 units will be 3. 3 units will be -3. Now, what I'm going to do is, I know that my period is going to go from 0 to pi, correct? One full cycle. So let's go ahead and just count. Let's just do the same so you guys can see the stretch. So just to keep them the x-axis as the previous one, let's do the same. So pi over 2, and then pi every 2 units. 3 pi over 2, 2 pi, 5 pi over 2, 3 pi, 7 pi over 2. Okay. Okay, so my key points, x-intercepts. The first one and the last one, right? And then what else did I have? The one right in between. Those 3 are intercepts. Now, what number is between 0 and pi over 2? Pi over 4. Is that the maximum, where the maximum happens, or the minimum? Maximum. What is between pi over 2 and pi? 3 pi over 4, very good. And that is where the minimum happens, right there. Now your graph will look like this. Did I mess up?
Yeah.
Sorry, Mia. I won't do it again. So again. I mean, it's not perfect, but close enough. What do you guys notice from that graph and the other two? It's more what? More compressed, right? Yeah, horizontally. So what happens is that here the period is pi. Here the period is 2 pi. So if we were talking about heartbeat, for example, which one will be more frequent? Okay, if the horizontal axis was time, which one will be more frequent? Depends on what?
It doesn't matter which one.
Okay, this is the person exercising, and this is the couch potato. What was the term that I used for the next level of couch potato?
Please.
How did I call you guys the other day? And I say you guys achieve the next level of couch potato-ness. Okay, it's not important. So which one will be more frequent? The heartbeat, the person exercising or the person who's not?
Exercising.
Yes, right, obviously. So what I'm trying to say is that if the period it is smaller, the frequency will be higher, all right? Because actually the frequency is the reciprocal of the period. And this will be 1 over 2 pi. Which fraction is bigger?
1 over 5.
1 over pi. Okay, going back to the handout. Okay, now we have a graph that has everything. And let's go ahead and recognize some of the letters here. So with the letter A will tell you the amplitude. In this equation, A will be the 4. This 2 will help you determine the period, which will be 2 pi divided by B. And this number here, the 2 pi over 3, is actually here the letter C. And that is going to give us the phase shift, which in other words is nothing but a horizontal translation or shift. And then there's one more letter. What letter do you guys think we'll use? Plus D. What do you guys think D will do? Yes. The vertical shift. This problem doesn't have one, but the one after will. Okay, so this is like your almost your graduation from sine waves, okay? Almost. You have one more. Oh no, that's the last one. Yeah, this is your graduation of sine waves. No. Okay, so we start with amplitude. Amplitude will be the absolute value of 4, which is just 4, and that tells me that the minimum will be -4, the maximum will be 4, and the range as an interval, it will be from -4 to +4. And that's it. Now, the period. We will take 2 pi, the original, and divide it by the constant that we have here, which is 2. So that will give us pi. So that means that the graph will complete one full cycle from 0 to pi. It will go up, intercept, down, and then up to intercept. Okay, what else? Oh yeah, the phase shift. So that's new for you guys. And so that phase shift, the book has a formula for it, and you have to do the following. You have to divide
C over B.
C over B? Okay, I thought it was B. Is it C over B? Yeah. C over B. Now, what is C? C is the 2 pi over 3. And B is this constant, the 2. Yeah, that's 2 sandwich rule. So 2 pi times 1 is just 2 pi. And then 3 times 2 is 6. Can we reduce this fraction?
Pi over 3.
Pi over 3. Yes. So what this means is that the very first point is not going to be at 0. So for our 5 key points, the very first one is going to be here, pi over 3. And now, do you guys remember horizontal shifting? I've been telling you since Algebra 2, it is counterintuitive. Yeah? So if we see a minus 2 pi over 3, do you guys think it's going to move? And okay, let me just back up a little bit. You might be thinking, why is it not moving 2 pi over 3 units to the right instead? Right? Are you thinking that, Peru? Okay. The reason for that is because we're changing the period of the unit. So that's why we have to use this little formula here. If we didn't have the 2, then the phase shift, yeah, it would have been 2 pi over 3. But since we are changing the period, that's why we have to do the phase shift, use a formula, and that's how we get the exact units. To the right, correct, because we have a minus here. Okay, so that will be our first point. Now we have here x2, x3, x4, and x5. Now, how long is the period? Pi. So could I get the last point, the last x value? How could I get that? Wouldn't it be, it was not pi, because we did not start at 0. Where did we start? So the last one is going to be what? Okay, should I add or subtract pi? Add. So it's going to be pi over 3 plus pi. And so that will give me 4 pi over 3. Okay, the point 2 could be pi over 3 plus another pi over 3, like the first one plus whatever the interval is. Okay, I'm sorry. Let me back a little bit. That is wrong. It could be right, but I'm not sure. Let's find out what the intervals should be. The first and the last point are good, I promise. So the intervals, remember, we take the period, and then we divide by the 4 intervals, the 4 spaces. So the period was pi. So the intervals are actually pi over 4. Ooh, interesting. You're going to hate this. So what that means is that we're going to keep adding pi over 4, okay, to get the x values. So in this case, it's pi over 3 plus pi over 4. And so if we convert that to 12, it will be 4 pi over 12 plus 3 pi over 12. And that will give me 7 pi over 12. The next one, it will be 7 pi over 12 plus pi over 4. Do you guys remember how I told you to learn fractions? Yeah? Because I do. Right, Vidyani?
Yeah.
Yeah, sure. Okay. So in this case, again, we divide by 12. So 7 pi over 12 plus 3 pi over 12. And that will give me, which reduces to 5 pi over 6. The next one will be 5 pi over 6 plus, again, pi over 4. So this will be 10 pi over 12 plus 3 pi over 12. So that will be 13 pi over 12. Okay. Now for your x-axis, I will just label it to whatever is convenient to you. What is the biggest denominator we have here? 12. So why don't we try to go for pi over 6 intervals? Or should we do, yeah, let's do pi over 6 intervals. What was the amplitude? 4. Yeah, so let's let's just make this 4. -4. So we go like right here, this will be let's make that pi over 6. 2 pi over 6, which is pi over 3. 3 pi over 6, which is pi over 2. No, is that right?
Yes.
Okay. 4 pi over 6, which is 2 pi over 3. 5 pi over 6. 6 pi over 6, which is pi. And then 7 pi over 6. And then 8 pi over 6, which is what, Vidyani?
So
8 pi over 6.
don't tell me that's when I got this. That's 2, that's 4, that's 3, 4, okay, 4 pi over 3.
Yes. The next one, what is it? Sebastian? After 4 pi over 3. So that was 8 pi over 6. So the next one will be 9 pi over 6. So divided 3 pi over 2. The next one will be what?
5 pi over 3.
5 pi over 3. Because it's 10 pi over 6. The next one is 11 pi over 6. The next one will be 12 pi over 6, but we can reduce that, right? That will be 2 pi. And let's just stop there. All right, let's go ahead and plot the key points. The x-intercepts, those were happening here. Where else? Did you guys tell me? X-intercepts, guys. Look at your handout. Come on, you can do it.
7 pi over 12. 4 pi over 3.
4 pi over 3. And what was the other one? 7 pi over 12, Danny?
Yeah.
Okay, where will that be? I know, I'm just... 7 pi over 12. Will that be less than pi?
Yes.
Yes. Will that be
Yes.
more than pi over 2?
No. Yes. No.
7 pi over 12, you guys said it, right? Yeah? Yes, it is more than pi over 2. Yes, it is. So it's actually right here, I think. Isn't it?
Yeah.
Yes. And so is that going to be a max or a minimum? Or did we say that was an intercept?
That was an intersection.
You were talking about intercept.
Yeah,
I
that
thought
was-
5 pi over 6 was the next.
Okay, so yeah, you guys are not telling me the correct thing. This is what I'm talking about, 5 pi over 6. Intercept. That will be, remember, the intercepts for sine are the first, the last, and the one in between. So it's 5 pi over 6. So 5 pi over 6 as an intercept, and then that will be the max. And then what was the minimum? Should be between these two, right? Right there. Oh, so pretty. Let's just wrap one period. Okay, word of advice, when you graph on your calculator, you must make sure that your graphing settings are in radians. If they're in degrees, you will not get the correct graph. To check your work, right, on the homework?
Yeah.
Yeah, sure. Uh-huh. Uh-huh. Okay, so let's move on. All right, now cosine is a little bit different than sine, so let's go ahead and just graph the parent function on this paper. Okay, so again, the x is going to be the independent variable, which will be the 3. Well, didn't you take a break? that way for transition? No. So in this case, the domain is the same. It's all real numbers. You remind me of my son.
Should I say thank you? Should I say that's me?
No, that's cute. Just say thank you. And we go out to eat, and it's like, okay, we're going out to eat. Do you need to use the restroom? We're not going to take you when we get our food.
On your little kid.
He never needs to go until we get our food. All right, now the amplitude and the period here is the same. So let's just go ahead and label that 1, and here 2 units, that will be -1. But with cosine, we're talking about that unit circle. We start here at 0, and we said that the radius of the unit circle was a what? A 1? Right? So what will be the x-coordinate of a point here? 1. So that point is here. So the cosine of 0 is 1. Now the cosine of pi over 2 is what?
0.
What is the cosine of pi? -1. Not +1, but -1. What is the cosine of 3 pi over 2?
0.
What is the cosine of 2 pi?
1.
1. And that right there is 1 full cycle or period. All right? If I want to draw another one, then it will look like this. Cycle. Yes, it does. And I'm glad you mentioned that, because what would you guys say that function is? Is it odd or even?
That is in.
Even. It's symmetric with respect to the y-axis. And in fact, there's a thing really interesting called Taylor series, or Taylor approximation of polynomials, and you use polynomials to approximate graphs like this, and yes, you use quadratics to approximate sine waves or cosine waves, in fact. All right, just quickly here, let's graph this one, and then that will be probably the last one we graph. I think that will be enough. How many more do we have? Oh, we have the word problems. Okay, so I'm going to have to ask you guys for a huge favor. And we're probably going to finish this in class. The last 2 slides, I really need you to watch them on video. And then you can watch what happened at minute 24. I'll see how bad it is.
Keep it.
I'll tell you.
Whatever. Okay, let's grab this one quickly, guys. So what we're going to do is what changes here is not the amplitude or the period. The only thing that changes is the key point. Because the sine function started at 0, and then it went up, and then it had an intercept here, and then it went down, and then it went back, like that. Okay? So the key points are now going to be the 3 intercepts and then the max min. In fact, the key points are going to be, well, let's talk about amplitude quickly first, since we already know how to get that. The amplitude is the absolute value of -3, which is +3. And then we have the period. Oh yeah, this one's kind of interesting, because the period will be 2 pi divided by this number. And like, it used to throw me off a little bit, because it does have pi. So look at what's going to happen when I divide that. 2 pi times 2 is what? 4 pi. And then what is 1 times pi? Pi. So what happens here? 4. And that's weird, right? But that's still in radians. If I ask you, what is pi less or more than 4 radians? Less, because what is this approximately? 3.14, right? So if I tell you 4 radians, it's okay. It's not a big deal. We could use radians without the pi. It's fine. So now to figure out the intervals between our key points, we could do the same thing. We divide the period by 4, and so that will just be 4 over 4, which is 1. So this is actually going to be pretty easy to graph. Now, speaking about key points, x1, x1 and x5, if there is no reflection, will be the maximum values, just like the parent function. However, here, do we have a reflection? Yes, we do, because there's a minus. So the first and the last point are going to represent the minimum y values. And what do you guys think this one in the middle will be? The max. Who said that? No, it was a girl. Good job. The max. And so what do we have to have between a min and a max? An intercept, yes. The intermediate value theorem, right? To go from up, down, you have to cross the x-axis. Okay, there is no phase shift here, meaning horizontal translation, so we could start at 0. And then our intervals are just by 1s. So this is 1, this is 2, this is 3, and this is 4. Just like that. Let's graph it quickly, and then you're free to go. Also, let's do it on the other side of your paper. Can someone read the equation to me, please? Negative 3 cosine is a pi over 2x?
Yeah.
Okay. All right, so we already agreed. Let's just label this one will be 1, 2, 3, 4. And we have here, let's count 3 units. That will be 3. This is negative 3. And so we decided that since there was a reflection, we're going to start at the minimum values. And then right in between, that will be the maximum. And then right in between those, the min and a max, there must be an intercept. And again, between the max and the min, there's an intercept. And so the graph will look like this. And then it will just go back up, and then down, and so on. All right? So you guys are good to go? Please, wait. I'm going to continue recording. Please watch the last 2 slides, okay? We cannot get any more behind. And I'm going to need someone from cosine team to fix that graph, okay? We're going to continue by graphing example 6. Just a small recap. Here is a graph of the parent function and the cosine. And so that is 1 full period or 1 cycle. So now we finished by graphing that graph, negative 3 cosine of pi over 2 times x. And so we could see that graph here. Let's just look at it quickly. So that is the graph. And now what we're going to do is record the one from example 6. And I believe that one is on the next page. Okay, so we're on the next page now. Okay, and so what we have here, it is another cosine function, and so we're going to graph that one. So we need to determine the amplitude first of all. And that comes from this number here, 1/2. So the amplitude will be the absolute value of 1/2. So that is equal to 1/2. Now we could tell that there's no vertical shifting, so we could tell that the minimum value, the minimum y value will be negative 1/2, and the maximum value will be positive 1/2. Now what we could also tell from here is that the range will be from negative 1/2 to positive 1/2, including those two numbers. Now for the period, we're going to look at this constant, is 4, and we're going to use it to determine our period by using the formula 2 pi divided by b. In this case, b is equal to number 4. So 2 pi divided by 4, that will, if we reduce, 2 can be divided by 2, so that will be a 1 pi. 4 divided by 2 is 2, so that reduces to pi over 2. So our period in this case is going to be much smaller. So this is going to be a very, very noticeable horizontal shrunk. Now, we do have a constant being added here, and that is pi. So we are actually going to use that constant to determine the phase shift of the equation. So the horizontal shifting, in other words. So the phase shift is going to be constant c divided by constant b. Now we know the constant b, we could take it from here. It was this one, the one that helps us determine the period, so we have to divide by 4. Now constant c, you may think it is positive pi, but in reality, we have to take negative pi. And so if you remember your transformations, when we have a constant being added, we say that it actually moves to the left. So it's going to move to the left by negative pi over 4 units. Also, another way to explain this will be that if you notice this formula here, it says bx minus c. So what I can do here is say 4x minus negative pi. And so once I get that, the minus, negative times a negative will give me plus, or positive, so plus pi. And that's what you could see here on your equation. But in reality, the constant that we need to write down here is going to be negative pi. So just think about what we used to think with horizontal shifting. It will always be the opposite because it is counterintuitive. Now, so we have the phase shift. We're done with that. So now let's go ahead and graph the function. So before that, let's go ahead and find our key points. And so we can tell that x1 is not going to be 0, but it's actually going to be this number here. That will be the very first number. Now, I would like to show you guys another way to find those numbers. And so remember, we've been talking about those key points. And actually, this might help you understand a little better why horizontal shiftings are counterintuitive. So what I'm going to do is, I'm going to erase a little bit. I'm going to have a mess here. So what I'm going to do is take what's inside this parentheses here, right here, the 4x plus pi. And so I'm going to create two equations, 4x plus pi, and one will be equal to 0, because that's where the regular cosine graph is where it will, the parent function, that's where it will start. And I'm going to create another equation that equals to 2 pi. Why? Because that's where the parent function ends, one complete cycle. This is where it starts, this is where it ends. So now what I'm going to do is solve for x. So on the first equation, I will have 4x is equal to negative pi. Now if I solve for x, I need to divide by 4. So negative pi divided by 4. So that number will be the number that I have here, for x1. Now, to find x5, I'm going to solve the second equation that I created, the one that ends at 2 pi. So this will be 4x is equal to 2 pi minus pi. So then 4x is equal to pi divided by 4. So that will be my very last point. Now, I want you guys to think of something. Do we have any reflection across the x-axis? We don't. So what it means is that this point, x1 and x5, are going to be my maximum, where the max happens. But the actual maximum value is going to be positive 1/2. And the y value that corresponds here is also positive 1/2. Now remember that right in between the two maximum values, it is the minimum value. And that y value that corresponds to it will be negative 1/2. Now how can we find the x value? Well, think about it. What is right in between negative pi over 4 and pi over 4? And the answer will be 0. So x equals 0, that will be that is where the minimum will happen. Now let's see if we can figure out what will be the value for x sub 2. Now there's several ways you could do this, but one thing we can do is by finding the midpoint, and the midpoint is actually going to be, if you divide this quantity by 2, you will get negative pi over 8. So that is where one of our x-intercepts will happen. And the other x-intercept is going to be right in between 0 and pi over 4. And so that will be positive pi over 8. Okay, so if you are watching this video, I'm going to be asking you some random questions on Friday, so please do not share with anyone. And so the first question is going to be, let me think. Why am I taking anatomy and physiology classes? That would be the question. So think about it for Friday. So anyways, let's go back and just let's go ahead and graph it now that we have all the key points. So we're going to graph it here. And remember that graph that we're going to, the function we're going to graph is going to be y equals to 1/2 times the cosine of 4x plus pi. Alright, so we decided that because of our phase shift, we were going to start, let's go ahead and label that negative pi over 4. So right here we will have positive pi over 4. Here we will have pi over 2. Here we will have 3 pi over 4. And here we will have pi. This will be 5 pi over 4. And we can keep going, but we're just going to graph one cycle because that's what the example is asking us to do. So we have our maximum points, and we want to have 1/2, so let's go ahead and make this one a 1. So this will be a 1/2. This will be negative 1/2, and this will be negative 1. Now let's go ahead and graph our maximum values, and so we decided that those were going to happen here and here. Then and I'm sorry, that's wrong because the maximum y value is not 1, it's actually 1/2. So that will be here and here. Now the minimum value is going to be at 0, negative 1/2. And right in between a max and a min, we have an x-intercept. And between the min and the max, we have the other x-intercept. And so this will look like this. And it should be a little more rounded. If we were to ask to graph more cycles, then we would just keep going in the same pattern. All right, so I'm going to stop there. Now let's move on to the next example. And now we're going to look at a vertical shift. And so this is going to change a lot of the way we find the maximum and the minimum. So before I get to that, I'm going to erase this equation just to make more room. And let's start by finding the stuff that we already know how to find, which is the amplitude. So for the amplitude, of course, we will need this. Oh, and actually, I think, oh no, it's not the same half, sorry. So the absolute value of 1/2, which is equal to 1/2. That's it. So originally, we would have said that our range, if we didn't have this vertical shift in here, we would say that our range will be from -1/2, that will be the minimum, and the maximum will be +1/2. But because we have this -1 here, and it is implying that there is a vertical shift of 1 unit down. So because of that, I'm going to go ahead and subtract 1 to both of these y values, and that will give me the correct range. And so maybe I should write it this way. So it will be 1/2, -1/2, -1. And the highest y value will be +1/2, -1. So that will turn into -1 is equal to -2/2. So here we will have -3/2. And for our maximum value, again, we have -2/2 plus 1/2, so that will be -1/2. So right here, this will be my minimum y value, and this will be my maximum. Now, the period for this function, it stays the same. And the period is going to be 2 pi divided by b, and b is the constant that goes here with the x, so it will just be 2 pi divided by 1, which is 2 pi. So the period is not changing, and if you notice, we don't have any type of reflection along the x-axis. So we could say that our x1 is going to represent our maximum value. Now here we don't have a phase shift or a horizontal shifting, so I'm going to say that my x1 will be 0. Now my x5, my last one, is going to be 2 pi. Why is it 2 pi? Because that's the period of the function. And of course, to find the one in the middle, oh, and moreover, this will also represent a maximum. That's where the maximum happens at. Now the point in the middle, which I'm calling x3, is going to be the midpoint between 0 and 2 pi, which happens to be pi. And that one is not going to be where the maximum happens, but where the minimum value happens. And so lastly, what we need to find is the other 2 points, which will be the x-intercepts. And those will be the midpoint between 0 and pi, and that will be pi over 2. The other x-intercept will be the midpoint between pi and 2 pi, and so that will be 3 pi over 2. And we know these are x-intercepts. All right. Now, for the y values, we already established that the minimum y value is going to be equal to -3/2. And the maximum y value is going to be equal to -1/2. The y value here, since it is an x-intercept, will be 0. And right here we have a max again, so that will be -1/2. So let's go ahead and graph them. And I'm sorry, actually I did make a mistake. I'm going to caught it before we started graphing. So, and it's actually a big mistake. We cannot refer to those points as x-intercepts because the points are not going to be located on the x-axis. Why? Because there was a vertical shift of 1 unit down. So those points, the y coordinates, are not really going to be 0. They're going to be -1. -1. And so because we're saying the y value is -1, we're not going to call them x-intercepts anymore. But what we're going to have in here is something called, some books refer to it as an imaginary line, meaning that right here at -1, we're going to have not really an asymptote, but we're going to use it more as a reference, like a reference line. So let's go ahead and graph it before we get to these two word problems. Okay, so we're going to graph it here. Okay, so let's start here. Actually, I'm going to go ahead and draw that line that I was telling you. And so that was, remember the equation is y is equal to 1/2 of cosine x minus 1. So that -1 is creating this line for us. So instead of having those key points going across the x-axis, we're going to have them going across that line. So our first point, which we say was the minimum, I'm sorry, the maximum, let's go ahead and label our y-axis. And so what I would like to do is, let's go ahead and call, this will be 1, and this will be 2. So now my line is not okay. So maybe this one. So if this will be -1, and this will be -2, and we'll trace that line again. Remember, this is not part of the graph, it's just a reference line. Okay, now our cosine started with a point at 0 for x, and the maximum value was -1/2. So 0 and -1/2, that would be. The other maximum value, if you look at your notes, it was at 2 pi over 2. So, oh yeah, let's go ahead and do those. So let's make this pi over 2, pi, 3 pi over 2, and 2 pi. So the other maximum value was at 2 pi. And the maximum value actually was negative. Yes, that is okay. The maximum y value was -1/2, and the minimum y value was -3/2. And all of that because this vertical shift. Okay, going back to, now let's go ahead and find the minimum value, and so that one, it's going to be right in between the two maximums, and that will be at pi. The y value will be -3/2. And that will be here. Now the 2 points that will normally be, that could have been the x-intercepts if it wasn't for this vertical shift. Those two points happen at pi over 2 and 3 pi over 2, but they're actually on that reference line that I was talking about. And so your graph after connecting the points will look like this. That will be one full cycle. If we were to keep going, then it will look like something. Not perfect, but pretty close. All right. Now, here, let's just do a recap. We had a vertical compression. We also had a vertical shifting. All right, so let's go to the board problems now. Okay, and this is one of those problems that I was referring to earlier about the breathing cycle of a person. So we have here the graph of the figure that you see there. It shows one complete normal breathing cycle. The cycle consists of inhaling and exhaling. It takes place every 5 seconds. Velocity of airflow, the velocity of the airflow is positive when we inhale. And it is negative when we exhale. So this is inhaling, and down here we have exhaling. Okay. And the whole process, the whole period, it takes 5 seconds. It is measured in liters per second. If y represents the velocity of airflow after x seconds, find the function of the form y equals a times sine of dx that models airflow in a normal breathing cycle. So what we're going to need here are, we're going to have to come up with our own equation. So we're going to need a number for A and a number for B. Now remember that A represents the amplitude and B represents the period. In fact, the period, it's more like 2 pi over B. So in this case, if we want to solve for B, we will be doing the following. We will be dividing 2 pi over the period. Okay, if you don't know how I got to this part, let me show you. So what I did is I took this B across. If I do that, it will be B times the period equal to 2 pi. And then to solve for B, period is multiplying B, so then I move it across, and it will be dividing. And that's how we're going to find B, by taking the 2 pi, the period of a regular sine function, and dividing it by the actual period of this function, which happens to be 5 seconds. So right here, the period, not the period, I'm sorry, the constant B is going to be 2 pi divided by 5 seconds. Why am I choosing 5 seconds? Because it tells me here that's the time it takes to go from this point to this point, 5 seconds. So that will just be this constant B. Now we have that. We need to find A, the amplitude, and the amplitude is actually pretty easy because we can look at that maximum value and we can look at that minimum value, and they match, they are the same, which tells me that there was no vertical shifting, and we could say that the amplitude will be 0.6. Now, I know it is positive 0.6 because this graph is starting from 0 and then it goes up. And so that tells me that there is no reflection across the x-axis, and therefore A is positive. Now that we have that, I believe that's all we need. And so we will take the original model, which is A times sine times B times sine of dx, So this B, remember we found that one, and we also found A. So our equation will be y is equal to 26 times sine of 2 pi times 5 x. And that's it. That is the equation. That easy. All right, let's go to the next problem. This one is a little more challenging, but not impossible. And this will be the last problem, I promise. And so we have a figure. We need to determine again what is the equation. And we're going to be using this model here. So if you notice here, we have several things. A is for amplitude. B is helps us determine the period by dividing 2 pi over b. And then we have C, which helps us with the phase shift. And we do that by dividing C over B. And finally, we have D, which will tell us the vertical shift. Okay, now we're asked to use sine again. However, well, no, not really. I cannot use cosine. Okay, so what we're going to take into account is the period that we see from here to here, but we should probably read the problem first. So modeling a tidal cycle. The figure 4.77 shows the depth of water of a boat dock. Okay, let me start again. Shows that the depth of water at a boat dock varies with the tide. So you may know that the water, the tide goes up and down. The depth is 5 feet at low tide, so that could be our minimum. And it is 13 feet at high tide, so that could be our maximum. On a certain day, low tide occurs at 4 a.m. And actually, that point, you can see it here. At 4 a.m., you have low tide. And high tide at 10 a.m. So that high tide, it will be at 10 a.m. and it will be right. If y represents the depth of the water in feet, x hours after midnight, so the independent variable will be the time, the hours after midnight. Use a sine function of the form, we already know the form is here, to model the water's depth. So what I did here is, if you guys notice, and we want to consider this cycle right here, the one traced in blue, we're not very sure of what the numbers are here and here, where the cycle starts and where the cycle ends. However, we do have a pretty good idea of what is the distance between these 2 points. We know that the time here is 4. We know that for sure. And we know that the time here is also, well, not also, but we know that for sure it is 16. So the reason I know that that is one complete cycle is because you notice how the graph starts and ends at the same position, which is the depth of the water of 5 feet. So what I can do is take 16 and subtract 4. And so that will give me 12, more specifically 12 hours. So now what I'm going to do is remember how we find the period by dividing the original period by a constant, let's call it b. Now what I'm going to do here is solve for b. And so to solve for b, I explained to you guys before, you could also picture as switching this 2, the b goes to the left multiplying and period goes to the right dividing. So to find b, I'm going to need 2 pi and divide it by the period. Well, the period happens to be 12 hours. So to find b, it will be 2 pi divided by 12. And so this will be pi over 6. So that is actually going to be not our period. Our period is 12 hours. But pi over 6 is going to be the constant that will be placed here. Pi over 6. Don't forget that. Now, we do need something for the amplitude. And so what we're going to do to find the amplitude here is going to be a little different than what we've been doing. But this is actually a good definition for amplitude. This is the definition for amplitude. And so the amplitude is the distance from the minimum point between the minimum and the maximum point, and then divided by 2. And so if I do this, I will get 18 divided by 2, which is 9. Now, the amplitude will be 9, which means that this constant right here, which is A, will be equal to 9. Actually, I want to make a correction. I'm sorry. Since I'm finding distance, not the midpoint, I should have subtracted here. So I'm going to say 13 minus 5 divided by 2. So I'm finding half of the distance between the maximum and the minimum. So in this case, 13 minus 5 is 8, divided by 2 is 4. So that tells me that the amplitude is equal to 4. So again, I took the maximum minus the minimum and divided by 2. That's how I got this number, 4. And so that will tell me the amplitude. Now, to figure out the phase shift, what we could do in general, let's work with the formula that we know for phase shift. And so let's call it P for phase shift. So that will be equal to C over B. And so right here, what we're going to do, so we're going to look at our graph. And we're going to estimate the x value that goes there. And that's one that I'm not like very comfortable with doing. But we're going to assume that that is exactly at the midpoint between those two. And so if we get the distance 10 and 4, the distance between those two numbers is equal to 6, right? And so the midpoint, that means that will be 3 units here, 3 units here. So that means that the value should be 7 right there. And so because of that, it's like we took this graph that could have started here and we shifted horizontally 3 units to the right. And so since we are saying that, we're going to call the phase shift, the phase shift is equal, no, I'm sorry, not 3 units, but 7 units. So the phase shift is equal to 7. Now, why do I need that? I need that because I'm trying to find this constant C, so that I can create my equation. And so C over B, we already know what B equals to. B is equal to pi over 6. So C over 1 over pi over 6. Now, I could do several things here. What I would like to do is just to get it over with and solve for C. I'm going to say, what is the pi over 6 doing to C? The answer is dividing. And so what I need to do is the inverse operation, which is multiplication. And so if I multiply by pi over 6, I will get 7 pi over 6 is equal to c. And so now I have that constant, and I just need one more constant. And that constant d is going to be the vertical shifting. And that one, we can actually find it pretty easily because it will be the exact midpoint between 5 and 13. Not the distance, but the midpoint. And so for the midpoint, yes, we could do this. 13 plus 5 divided by 2, and that will be 18 divided by 2, and that will be equal to 9. And actually, that kind of makes sense because you can see that imaginary line going there across 9. So now we have all of our constants. D is equal to 9. And so to write the final answer for this question, it's going to be y equals, we need A. A, we found it here. So 4 times the sine of, we need B. B is right here. Pi over 6 times x minus, we need C. And C, we actually found it right here. 7 pi over 6, close parentheses, and now we need plus D. So D happens to be 9. And that is the end of this video. I want to also share with you guys that my favorite color is purple, so I might be asking you that tomorrow. What else could I tell you? I can't really think of anything else, but I might give you a quiz to see if you watched the video.